In this video, we're going to have a look at something called non-right-angled trig. So in the past, when we've looked at traditional trigonometry, we had the sine, the cosine, and the tangent ratios. So the sine was the opposite over the hypotenuse. The cosine was equal to the adjacent over the hypotenuse, and the tangent was the opposite over the adjacent. And the way in which we labeled this non-right-angled triangle over here was we said relative to the angle theta, the side opposite was equal to the opposite side. The side next to this theta, we called that the adjacent, and the side opposite the hypotenuse, or opposite the right angle, we called the hypotenuse. Now what we're doing in this video is we're moving away from right-angled trigonometry, and we're going to add some tools to our toolbox that will help us analyze non-right-angled trigonometry or non-right-angled triangles. And the way in which we're going to do that is using something called the sine rule. So the sine rule we can write as sine A over A equals sine B over B and sine C over C. Now, to make use of this rule here, what we have to do is we have to use a new naming convention for our triangles. And with non-right-angled triangles, notice that we don't have a right angle, and we don't necessarily always have one angle to work with. So in this case, what we do is we arbitrarily name each corner of the triangle, or each angle of the triangle, A, B, and C. And then the side opposite the corner inherits the lowercase letter of this. So in this case, the side opposite the angle A we call little a, the side opposite the angle B we call little b, and the side opposite angle C we call little c. So now that we've named our triangle, what we can do is we can use this rule here, the sine rule, and we can use this sine rule to find unknown angles and unknown sides within a triangle. So in this case, what we're going to do is we're going to use the sine rule here to find the unknown value x. So looking at the quantities I have, I've got angle A, I want to find little a, or side A, we've got angle C, and I want to find, or we've got side little c. So what we can do is we can grab this relationship here and this relationship here. And what we'll write at is sine A over little a equals sine C over little c. And then I'm going to flip everything upside down. So sine A and C sine C. And now that I've got it all flipped around, what I'm going to do is sub in my values. So upstairs for A, it's going to be x, and then downstairs, sine A, that is going to be 30 degrees. Now on the other side, for C, it's going to be 20 divided by sine C, which is 45. Now rearranging to solve for x, I'm going to get x equals 20 sine 30. Let me do that in a different color actually. Go 20 sine 30. So this is multiply, and then we're still dividing everything by sine 45 degrees. Now if I put this in my calculator, it's going to give me the answer. So what I'll do is I'll quickly type it in my calculator. So putting this in the calculator, we find that x is equal to 14.144. So our side length here, x, x is 14.144. Now to verify that that solution is correct, what I'm going to do is I'm going to look at this angle here, and it's 30 degrees, and this angle over here 45 degrees. The opposite side is a length of 20. Now comparing it to the angle with 30 degrees, 20 is greater than 14.144 and 45 is greater than 30. So because the bigger angle has a bigger side than the smaller angle with a smaller side, I know that's correct. If the answer came out and this value here was greater than this side here, I'd know I'd made an error, but it seems to look alright so far. Now let's go down to another example and consider we've got this triangle here, and notice that we've got the unknown angle that we're trying to find. So what we can do is we can annotate this triangle. So we'll call this C, we'll call this A, and we could call this B, but it's really not important because it doesn't give us any information. Now the side opposite the angle A, we'll call that little a, and the side opposite angle C, we'll call that little c. Now using the sine rule, what we can say is that sine C is over little c is equal to sine A over side length A. Subbing in the values, sine of theta divided by 5 equals sine of 45 divided by 30. Rearranging, we're going to get sine of theta equals 5 sine 45 degrees all over 30, and then the inverse sine on both sides. So inverse sine of 5 sine 45 degrees all over 30. If I put this in my calculator, entering that in my calculator, what I get is an angle of 6.768 degrees. So what that means is this theta over here, so this angle here is equal to 6.768 degrees. So that's how we'd use the sine rule to firstly find an unknown side length, so x in this question, and then how we can use the sine rule to find an unknown quantity here, so this theta, or find an unknown angle